Hello students, and welcome to today's lab where we are evaluating three different solutions. We are testing the halide content of X, Y, and Z. We're going to do this by adding silver nitrate and then ammonium chloride. In this particular lab, since we are evaluating three different solutions, we want to make sure that we are being good with our lab procedures. And so the first thing that we're going to do is we're going to go ahead and indicate for all of them we're going to indicate which solution is going to be in each one of them. Okay, so to help us do that, we're going to go ahead and take a grease pen. And a grease pen in this classroom is going to be a red pen like this. It has a marker on it, and we will go ahead and be able to label them as A, B, C, or D. Okay, the first one we're labeling X, Y, Z, and lastly we're going to do W because we're going to go ahead and put the sink water in W. Okay, this is a qualitative lab. So for the qualitative lab, what we're going to do is we're going to go ahead and just put a little bit of each one into the corresponding test tube. We're going to take a note of how each one looks before we add anything to it. And as you can see here, for all of these, we end up having three clear solutions. We'll spin our test tube around here. We have three clear solutions, and now we'll go ahead and add in our solution. We're going to start by adding in some sodium nitrate. Okay, sodium nitrate, whenever you work with it, you're going to want to use gloves because it does have the propensity to stain hands. And when we add the sodium nitrate, what's going to happen is that the silver nitrate, what's going to happen is that the silver ion is only able to be soluble when it is with nitrate. And if we have any other halides in there, the silver is going to attach to the halide, and when it does that, it will not dissolve in the solution anymore. So an example would be that if there was chlorine in our test tube, it would bang against the chlorine, and when it banged against the chlorine, it would end up precipitating out of solution and making a solid. So we're going to go ahead and do this experiment now, and we're going to take and put just a couple of drops in here. And as we can see, we have our first precipitate. We'll put the same thing in our second test tube, put a couple of drops in our third test tube, and finally our last one with the water. Okay. And our goal with these is we're trying to evaluate what each one may have in it. Okay. And we can go ahead and shake it up, and here we could see this one in particular, it ends up having a very, very yellowish color. Okay. and it is precipitating out some solid, and we can see that that solid is starting to flow down there at the bottom. This one right here ends up being a very, very bright white, silvery color, and if it'll focus, you can see that we have some of that white, silvery stuff is coming in at the bottom. We'll go ahead and give this one a shake as well. You see that it's precipitating out rather nicely. Okay. Our final one is this one here. And as you can see, right next to the other one, it looks like it's a little bit more white and a little bit more yellow, and it's the one that's right in the middle. We give this a shake, and you'll notice that this one also has those solid particles that are starting to flow down there, provided that it refocuses on the thing that we want it to. Okay, and you can see those particles coming out there. The last one is our city tap water. Okay, and our city tap water, you should notice that this also has a precipitate that's coming out here. Okay, it has changed color, and it seems to be closest to our silvery color. So that means that whatever is in test tube Y is going to be the thing that's also in our tap water. So the next thing that we're going to do, besides shaking these up here, is that we have a second test that we can do. And the second test that we can do is that we can add a little bit of ammonia to each of these, okay? And when we add a little bit of ammonia to each of them, what's going to happen is that we are actually going to be messing slightly with the concentration of silver ions. So this is going to mess with the concentration of silver ions, and it will grab onto the silver ions and keep them into solution. And when we do that, it's going to push the equilibrium away from becoming a precipitate. And the reason that it does that is that there's no more silver ions competing. So any silver ions that want to go into solution will be able to do so without any competition from the silver ions that are already in solution. So this is going to be something that if it affects the solution, it'll help us to narrow it down. The reason that it's going to help us narrow it down is because two of the solutions have two of the solutions will be affected by it because they have a relatively high solubility compared to the third. Okay? And the high solubility means that it'll be affected when we add something that increases the solubility. Whereas the iodine, it has such a low solubility that by adding some ammonia in, it won't actually affect any of the dissolved solution that's in there. All right. So in this case, we're going to go ahead and pour some into our first container, our second container, and our third container, and fourth. Okay. And when we do that, we'll go ahead and shake it up again. And we're going to see if the solution ends up getting a little bit lighter because there's more silver dissolving. Okay. This first solution, it doesn't seem to be getting much lighter, and in fact we could still see that there's a gradual amount of precipitate forming still. The second one, when we shake it up, we see that there has been a gradual change, that we have less dissolving in it than before. Okay. In fact, we can end up seeing that it looks like it's been diluted just a little bit more, which is what we would expect to see as some of the stuff that was the solid is dissolving again. Okay, the same thing that we can also see at the bromine for test tube Z, that we aren't seeing a large change, and we're not seeing all too much of a change here. Okay. You can see for two of the test tubes that it's relatively clear at the bottom, which means that we're not getting any precipitating down forwards. Whereas the one that's all the way to the right here, it is very, very murky there because of how much of it is precipitating out. And we can say without a doubt now that because iodine is not affected, that this test tube that's in test tube X is likely to be iodine. Okay. The rest of the test tubes you're going to have to evaluate on your own to see which test tube has which kind of halide ion. And at this point, I'm going to go ahead and close out this lab portion, because you should have all the information you need to finish the lab for today. Remember, stay lazy.